Next is question number 5. You may take the screenshot of the questions from part 1 of the video on electric current numericals. So question 5. In the circuit given below, EMF is 9 volt and there are two parallel resistances 1.5 and 3 ohm and two parallel resistances 6 and 12 ohm, and this combination is in series with the other combination. So we have to find the first main current. First we have to find the main current or the total current. Main currents mean total current. So total current is equal to, because V is equal to IR, so V upon R is equal to I. I will be the R total. I will be the total resistance of the circuit. So total resistance is, this is 1 and this is combination 2. So it is combination 1 in parallel with the combination 2, in series with the combination 2. For combination 1, R equivalent is, because they are in parallel, so R equivalent is, we have 1 by R equivalent is equal to 1 by 1.5 plus 1 by 3. So we can write it as 10 upon 15 plus 1 by 3, and we can take the LCM as 15. So this will be 10 plus 5 3s are 15. So this comes out to be 15 upon 15 is equal to 1. So R equivalent is 1 here. So this is the EMF 9 and we have R equivalent of first combination is, it is 1 ohm. Now we have to find the R equivalent of the second combination. Combination second, R equivalent is 1 by R equivalent is equal to 1 by 6 plus 1 by 12. So 12 is the LCM. 6 2s are 12 plus 1 is equal to 3 by 12 is equal to 1 by 4. Therefore, R equivalent will be, its reciprocal is equal to 4 ohm. So the second will be 4 ohm. Second resistance is 4 ohm. So total resistance will be, C1 is in series with C2. C1 is in series with C2. So we will get 1 plus 4 ohms is equal to 5 ohms. So this total comes out to be, if we get total equivalent resistance of the circuit, so total is 5 ohm. Because the total is now 5 ohm, therefore the current in the circuit is V upon R total. So it is, V is 9 volt and R total is 5. So it is 9 upon 5 amperes. So it comes out to be 5 1s are 5 and 5 8s are 5 1s are 5, 40, 5 8s are 40. 1.8 ampere. 1.8 ampere comes out to be the total current. So total current is 1.8 ampere. So everywhere total current is 1.8. Here also total current is 1.8 ampere. Second, we have to find current in each of the circuits. Now we have to find current in each circuit. Current in each circuit. So the current in each circuit is so we have to find the potential drop across each circuit. First we have to find potential drop. The potential drop across 1.5 and 3 ohm resistance is same because these are in parallel. Similarly, potential drop between 6 and 12 is also same. So it comes out to be, the equivalent of this resistance is 1 and equivalent of this is 4 ohm. So here current is I. Current is 1.8 for 1 ohm resistance. For 1 ohm resistance, current is equal to 1.8 ampere. Therefore, potential difference will be, and R is equal to 1. So potential drop will be I into R is equal to 1.8 into 1 is equal to 1.8 volt. So potential difference here is potential difference V across 1 ohm resistance is 1.8 volt, and potential difference across other will be 9 minus 1.8, because total is 9, total potential is 9, so 1.8 is dropped across this resistance, rest is dropped across 4 ohm resistance, which will be 7.2 volt. Rest is 7.2 volt. Therefore current through, now it means 1.8 volt is the potential drop across 3 ohm resistance as well as across 5 ohm resistance. Potential drop is 1.8. Similarly, potential drop is 7.2 across 2 ohm 12 ohm resistance as well as 6 ohm resistance. So current across 1.5 will be, current will be potential upon resistance, I is V upon R. So it is V is, for this, for 1.5 V is 1.8 and V by R is 1.5. So 1.8 divided by 1.5, so 5 6 ja 3 6 ja 18, 3 5 ja 15, and 5 1 ja 5, and 5 2 are 10, is equal to 1.2 ampere. 1.2 ampere. So 1.2 ampere is the potential drop across the resistance. 1.2 is the current through the resistance 1.5 ohm, and therefore current through 3 ohm resistance will be, current through 3 ohm resistance will be simply, total is 1.8, so 1.8 minus 1.2 is equal to 0.6 ampere. Similarly, we will find for 6 ohm resistance, current across 6 ohm resistance is V upon R. V here is 7.2 and R is 6 ohm. So it is 7.2 divided by 6. So 6 ones are 6, 6 twos are 12. So it is 1.2 ohm, 1.2 ampere. Similarly, current through the 12 ohm resistance will be, current through 12 ohm resistance will be 1.8 minus 1.2, it comes out to be 0.6 ampere. So this is the value of current through each of the resistance. Then we'll move to the next question. So our next question is question number 6. We'll do question number 6 now. You can take the screenshot of the questions from the part 1 of the video. In the starting of the part 1 of the video. Now is question number 6. The length of the resistance of a stretched length wire of length L is 6 ohm. So wire of length, there is a wire. So its length is L and its resistance is 6 ohm. So it is stretched. The wire is stretched, and after stretching its length becomes, after stretching its length becomes 12, and its resistance we have to find. We have to find its resistance after it gets elongated. So there is a hint that when the wire is stretched, its area of cross section is reduced while its volume will swing. The volume remains the same, but its area of cross section is reduced. We have to find the new resistance. So we'll use the formula. We know that R resistance is equal to rho times L divided by A. So resistance is rho times L divided by A. Now what is rho? Rho is the specific resistivity of the material, and rho is constant for a given material. For a given material, resistivity rho is constant, so it will not change. Even if the length of the rod is changing, still the resistivity rho of the material will remain the same. only length and area is changing. Both the length and area is changing on stretching the wire. So the resistance will be changed. So let R1, resistance 1 is rho into L1 divided by A1, and resistance 2 will be rho into L2 divided by A2. Now we know that the length volume remains the same. So we can write R as rho L by A, and if we divide and multiply by L, there is no difference. If we divide and multiply a number with the same number, then results remain the same. So we can divide and multiply with L. So if we divide and multiply with L, we get R is equal to rho into L squared divided by A into L. Now what is A into L? Area into length is the volume of a cylinder. The wire is cylindrical in shape. So A into L is the volume of the cylinder, where A is the area of the cross section, L is the length of the wire. Therefore R comes out to be rho L square divided by V. Now from here we come to know V is constant, rho is also constant because it is constant for a material. V remains constant on stretching the wire. So we can say R is directly proportional to L squared. R is proportional to square of length. So L length changes from L to 2L. So resistance will change from resistance if the length is changed 2 times. Resistance will change 2 raised to power 2 times, because it is proportional to the square of length. So if length is changed 2 times, the resistance will be increased by 4 times. So the new resistance will be 4 times the previous resistance. New resistance will be 4 times the previous resistance, which is 4 into 6, and 6 4s are 24. So 24 ohms is the new resistance of the wire. 24 ohms is the new resistance of the wire after it gets stretched. Now we'll move on to the next question. Now next question is question number 7. Now we'll move to question number 7. Sorry. Now question number 7 is find the equivalence equivalent resistance between point P and Q. So this is point P. We have a resistance and again a second resistance and third resistance, and in parallel with this resistance there are 2 more resistances. So we can see these 2 resistances are in parallel with the 3 resistance. So don't go for the shape that is it is V shape. This can also be written as, we can also draw it as so these resistance can also be drawn like this. So these 2 are in parallel to each other. The 2 resistances are parallel to each other, in series with each other, and it is in parallel with the third resistance. So here it is 3 ohm, so it is 5 ohm, it is 10 ohms, and this is again 10 ohms, and this is 2 ohms. So again 3 ohm, 5 ohm, and 10 ohm, these 2 are in series with each other, and this is our 2 ohm resistance. Last is the 2 ohm resistance. So this is how we draw this circuit. Why these are in series? Suppose current I is coming from here, so it will come here also, but from here it will get divided into 2 parts, I1 and I2. So I2 current will pass through 5 ohm resistance and will come out of it, but I1 will pass through 10 ohm resistance also and the second 10 ohm resistance also same current I1 is going to pass. Therefore, the two resistances are in series with each other, and the combination of the two resistances, the combination of these two resistances, this combination is in parallel with the 5 ohm resistance. Why? Because see the ends, the end of this four combination, the two ends and A and B, the two ends of these two combinations and the two ends of 5 ohm resistance both are connected to the same point. These two both are connected with the same point. Therefore, there will be same potential drop across these two. Across these two means same potential drop between 5 ohm resistance and the same potential drop across the combination of 10 ohm resistance. So total resistance potential drop across AB will be same. Therefore, these are in parallel. Now we have to find the equivalent resistance. So what is the equivalent resistance between point P and Q? Equivalent distance between point P and Q, this comes out to be so we'll go on simplifying this. So this will become P and this is 3 ohm, and then these are, because these are in series, it will become 10 plus 10, so this will become 20 ohms, and this is 5 ohm. So 20 ohm in parallel with the 5 ohm, and then again there is 2 ohm. Now we have these three, 1, 2 and 3 are in parallel series. 1, the whole combination, and 3. 1, 2 and 3. These three are in series. So now we have to find the equivalent of this parallel equivalent. So this will become P and 3 ohm, and the parallel combination of 20 and 5. So R equivalent, 1 by R equivalent is 1 by 5 plus 1 by 20. So 20 is the LCM, divided by 25, 4s are 20 plus 1. So it is 5 by 20. So 5 4s are 20. 1 by 4. So R is 4. 1 by R equivalent is 1 by 4. R is 4. So this is P, and then we have 4 ohms, and then we have the last 2 ohms. So finally we get P equivalent is equal to 3 plus 4 plus 2. So this is 9. So total is 9. Total equivalent resistance across the PQ is 9 ohms. So this is how we solve this. Each and every step you have to note and understand. And then we'll move to the next question. Now we'll move to the next question. So next question is question number 8. 3 resistances are connected to a 6-volt battery as shown. So find the, yes, this is a circuit. So question number 8 it is, we have a circuit. So this is 7.2 ohm resistance. Then we have 2 resistances which are in parallel to each other. The 2 resistances are 8 ohm resistance and we have 12 ohm resistance. These two are in parallel, and these are in parallel, and these are across a 6-volt battery. Across a 6-volt battery, and we have a key here. Now we have to find the equivalent resistance of the circuit. So simple, R equivalent is equal to, first we have to find the equivalent resistance of 1. R equivalent of 1 is 1 by, R equivalent of 1 is 1 by 8 plus 1 by 12. So LCM is 24. So 8 3s are 24 and 12 2s are 24. Divide by 24, we get 5 by 24. 5 by 24 is the R equivalent. It comes 1 by R equivalent. So R equivalent is 24 divided by 5. So 24 divide by 5 is, we get 5 4s are 20.8. 5 8s are 40, 4.8 ohms. So we can rewrite this circuit as two resistances 7.2 ohm and second resistances we get R equivalent 4.8 ohm are in series with each other and across a 6-volt battery. Now R equivalent, final R equivalent or R total is parallel combination of 7.2 ohm plus 4.8 ohm. It comes out to be 7 plus 4 11 and 12. So it comes out to be 12 ohms. So total is so this is equivalent to one resistance of 12 ohm across a 6 ohm resistance. So this circuit is equivalent to this circuit. After that we have to find the current in the circuit. We have to find the current in the circuit. So what is the current? So current is equal to V is equal to IR, V upon R is equal to I, V upon R. So it is total potential 6 and total voltage resistance is 12 ohm. So 1 by 2 is equal to 0.5 ampere. 0.5 ampere is the current in this circuit. So the current through the battery is, main current is 0.5 ampere, and last we have to find the potential drop across 7.2 ohm resistance. Potential drop across 7.2 ohm resistance. So again potential drop across 7.2 is I into R. What is I? I is the current and R is the resistance. Current is 0.5 and resistance is 7.2. So this comes out to be 7.2 divided by 2. 2 3s are 6 and 2 6s are 12. So 3.6 volt. 3.6 volt is the potential difference across the 7.1. So the potential difference of 3.6 volt is the total potential difference across the 7.2 ohm resistance. Now last question for this video, then other question will continue in the next video. So this is the last question of the video. The questions are in first video, questions 1 to 9 are there. So in next video other questions will be discussed. Question number 9, find the equivalent resistance between point A and B. So this is point A and we have to find the equivalent resistance between point A and point B. We have to find the equivalent resistance between point A and point B. The resistances are 6 ohm and 4 ohm and 3 ohm, 2 ohm, and this is the 30 ohm resistance. We have to find the equivalent resistance between point A and B. So again we can see if current I is coming, it will be distributed in 3 parts. So current I will be distributed in 3 parts. Current I will be distributed I1, I2 and I3. So I1 current will go from the resistance 3 ohm and 2 ohm. Therefore 3 and 2 ohm are in series with each other. I2 current will be from 30 ohm resistance and I3 current will be from 6 ohm and 4 ohm resistance. Therefore 6 ohm and 4 ohm resistance are in series with each other, and because all the 3 systems are connected between the 2 same points. So like this we can see. So we have like this. Now we have current is coming I1, I current is coming. So I1 here, I2 here and I3 current will go here. It means, and the same I1 current will go from here, the same I2 current will go from here, and all the currents I1 plus I2 plus I3 will come out from these 3 branches. It means this whole this whole network is in series to each other, means 1 and 2 are in series with each other. Similarly, this whole network is in series with each other, 1 and 2, 3 and 4 are in series, and this network number 1 is in the equivalent of this network 1 is in parallel with 5 and equivalent of the network 2. These 1, 2 and 3 will be parallel to each other. So how will we break the circuit? So this same circuit can be drawn as, this is point A. So we can draw it like this also, 30 ohm resistance, then 2 resistances, 3 and 2 ohm parallel to each other, 3 ohm and 2 ohm, and again there are 2 more resistances parallel to each other. These are 6 ohm and 4 ohm. So you can see this circuit and this circuit both are same. Both circuits are same. Only the shape is different. So if the shape is different, it doesn't mean the circuit is different. The circuits are same. So the two are in series. So we have to get the equivalent. So equivalent is, we get, so 3 plus 2, it is 5 ohm, and this is 30 ohm, and our last is 6 plus 4 is 10 ohm. 6 plus 3 is 10 ohm. So we get 5 ohm, 30 ohm and 10 ohm are in series, are in parallel to each other. Therefore R equivalent will find 1 by R equivalent will be 1 by 5 plus 1 by 30 plus 1 by 10. So 1 by 5 plus 1 by 30 plus 1 by 10 comes out to be, the LCM is 30. So 5 6 are 30 plus 1 plus 10 3s are 30. So 6 plus 3 9 plus 1 10 divided by 30 is equal to 1 by 3. 1 by R equivalent is 1 by 3. R equivalent is 3 ohms. R equivalent is 3 ohms. It means this circuit is equal to A and 3 ohms and B. So 3 ohm is the equivalent resistance between point A and B. Carefully note how we have simplified the circuit or how we have broken down the circuit. This is ICSE 2000, ICSE board 2011 question. These are our previous year questions. So carefully note how we have done. The next video will continue with the next questions.